Hello everyone. From today onwards, we are going to start our first unit, that is moment of inertia. Okay. So during our first lecture, we studied about the nature of the syllabus. We studied about the paper structure, and from that nature of syllabus and paper structure, we are quite familiar of this name moment of inertia. Now, this particular topic, moment of inertia, which has been allocated 6 marks as per the MSBT curriculum, but it will have 10 marks when you look at the question paper. Okay, so out of 70, 10 marks is a good thing. So it will have a good percentage. At least 3 to 4 questions will be asked on this particular topic. Okay, and so in this topic also we will have two types of questions. That is, we will have some theory content also, and we will have numerical content also. The theoretical content is limited. Okay, from this particular lecture we will start with the theoretical content and then we will move towards the numerical content. Okay, so let's begin. So first of all, what exactly is moment of inertia? Let us go through the definition of moment of inertia. So the definition of moment of inertia is defined as the product of area of a section and the square of distance between the reference axis and the center of the section. Okay, so from this particular line we have the definition of moment of inertia. So to understand moment of inertia better, let us consider one example. Let us consider a plane figure. Okay, suppose this particular is a plane figure. Okay, let it have some area A. So of this area A, let this much portion, as you can see over here, this much portion, let it have the area dA. Okay, so this small area will be dA. So let there be two axes outside the plane. One axis will be y, the vertical axis, and another axis will be x, the horizontal axis. Now suppose this particular smaller area of this plane. Okay, what we are doing here, we are taking just a small piece of area from this whole plane, whose area, the small portion will have the area dA. Now this region, or the distance between OX, that is our x-axis, and this point or this area dA, let us consider it as y. Okay, and the distance from the y-axis to this particular area, let it be x. Now what moment of inertia says? Moment of inertia is the product of area of section and the square of distance between the reference axis and center of the section. Okay, so what is moment of inertia once again? Moment of inertia is the product of area of section. So area of this particular section is dA and square of the distance between the reference axis and the center of the section. So if we consider this particular point as a centroid and this axis, x-axis, as our reference axis, the distance between this particular centroid and our reference axis is y. So accordingly we will have moment of inertia as dA into y square. Why like this? dA is nothing but the area of this particular section, and y is the distance between the x-axis and this particular section. Okay, so area again. So what is moment of inertia? It is the product of area. So dA is our area and square of the distance between the reference axis. If we consider x as the reference axis, then square of the distance between reference axis and the centroid, so it will be y. So dA into y square, product of area of section and the square of distance between the reference axis and the centroid of the section. So dA into y square. Now you must be wondering why I have written here Ixx. So generally moment of inertia is denoted by I, capital letter I, and at which point we are taking, or at which reference axis we are taking, that particular axis is denoted with the subscript of this I. So if we are taking moment of inertia at x-axis, we will write moment of inertia about x-axis as Ixx. Okay, similarly if we are going to take moment of inertia about y-axis, we will write it as Iyy. So again area is dA, same area is taken from this particular reference axis, and the distance from this axis to this area is x. So dA into x square, product of area and square of distance. So Iyy is nothing but dA into x square. Okay, I think you are now clear with the definition of moment of inertia. Okay, now you must be wondering, what is centroid? A centroid has many names. We call it as centroid, or we term it as center of gravity mostly. So center of gravity or centroid is that particular point which is considered to possess the whole weight of the body, or whole mass of the body is considered to be concentrated at that particular point. So it is assumption. Okay, for example, if you are considering a two-wheeler vehicle, suppose you are considering a two-wheeler motorcycle. So for that motorcycle, imagine a motorcycle in front of you. So above will be a seat, below that seat there will be an engine. So as you know that engine is the most weighted part, or engine has the maximum weight of the vehicle, so the center of gravity will move downwards. Okay, why? Because center of gravity is that particular point where we consider the whole mass of that body. So here center of gravity or centroid is thus defined. Okay, now moving forward. Now what is unit of moment of inertia? If we consider in mm, we will have moment of inertia is mm raised to 4. In centimeter, cm raised to 4. And in meter or in SI, we will have it as meter raised to 4. Remember, it is very important point, because we have seen that students tend to make mistake when you have to calculate the particular moment of inertia in the given example or the given numerical. You have to write its unit also. Generally here in our syllabus, in this particular diploma syllabus, we will take the unit as mm raised to 4. Remember that. Okay, and this particular point of definition is also very important. See, as you can see over here, definition was asked multiple number of times. It was asked in last 5 years, 4 times it was asked, and was asked for 2 marks. Okay, so when you are going for 2 marks, your approach will be not to just write the definition from here to here. You have to write the whole thing. Okay, so you have to write the definition, you have to draw the diagram, and you have to explain what is Ixx and Iyy. Remember, if you write there the unit of moment of inertia, then it is okay. You could write the unit of moment of inertia during this particular question of definition, then too it is okay. But at least you have to write the definition, you have to draw the diagram, and you have to write the Ixx and Iyy when the question of definition is asked for 2 marks. Okay, remember this. I think now you are clear with moment of inertia. Okay, now let's move forward. Our next thing, after moment of inertia, the next most important theoretical point is radius of gyration. Remember, this is also a theoretical point. Numericals will be asked on that. We will see it later. So let us go through the definition of radius of gyration. So radius of gyration is what? Radius of gyration is defined as the distance from an axis at which the mass of body may be assumed to be concentrated. Generally, it is denoted by letter K. Okay, so we will have 2 K's. K. The mathematical expression of K is square root of I by A. Now what is I over here and A over here? So I is nothing but the moment of inertia. In the definition of moment of inertia, we have seen I. So I is nothing but the moment of inertia. It can be Ixx or Iyy depending upon that particular reference axis. Okay, and A is nothing but the total area of that particular plane figure. Okay, so from that we will have K is equal to square root of I by A. If we consider radius of gyration about XX axis, we will write it as Kxx, and we will have the formula for that as square root of Ixx upon A. So same formula is there, but if we are considering about x axis, we will write it as Kxx, and the formula will just change to square root of Ixx upon A. So instead of writing I, we will write here Ixx. A will be the same. If we consider about x-axis or y-axis, the area of that particular plane is not going to change. That area will remain same. Okay. Similarly, if we consider the radius of gyration about y-axis, then we will write it as kyy. So kyy will be equal to square root of Iyy upon A. So instead of xx, you will write yy. So that much is only the change. That change happens because of the choosing or the selection of the reference axis. So when we will go through the numericals, you will get the better idea about this. Okay. So what will be its unit? The unit of radius of gyration is nothing but mm, centimeter, meter, etc. Remember, mostly during our numericals, during the examples that we'll solve in coming lectures, we will write the moment of inertia in mm raised to 4 as its unit, and we'll write radius of gyration in mm as its unit. Okay, so are you clear with this particular point? Once again we'll go through this. What is radius of gyration? It is the distance from an axis at which the mass of body is assumed to be concentrated. What is its formula? K is equal to square root of I by A. What is its unit? Its unit is mm. Okay, so these things you should know about radius of gyration. Okay, now let's move forward. So again, this point was also asked 2 times in last 5 years. It was asked for 2 marks. So what you have to do for 2 marks? You have to write the definition and you have to write the formula till here. Okay, there is no need to write about xx and yy until and unless asked. Okay, you can write its unit, but you are not supposed to write all this here, all this thing that is about xx and yy. Okay, so you can write from definition to the formula till here, from definition to the formula of k till here, and then you can write the unit of radius of gyration. Okay, so moving forward, the next and another one of the most important point in this particular topic is parallel axis theorem. Now, many of the students who have done their 11th and 12th, they must have encountered this point in the physics. Okay, they must have studied the they must have studied the parallel axis theorem over there. Okay, there is a slight difference between that parallel axis theorem which those students studied during their 11th 12th course and the particular parallel axis theorem that we are going to study in this course of strength of materials. So what is the difference? So to know the difference and to understand parallel axis theorem, let's move forward with the statement. So what parallel axis theorem actually states? It states that the moment of inertia of a plane section about any axis parallel to the centroidal axis is equal to the moment of inertia of section about the centroidal axis plus the product of the area of the section and the square of distance between the 2 axes. So when we look at this particular theorem, what we find? We find a very big statement over here. But let us divide this particular statement into small parts. Then it will be better for us to understand what this parallel axis theorem is particularly talking about. So what this parallel axis theorem talks about? Let's go through it once again. The moment of inertia. So this particular parallel axis theorem is talking about the moment of inertia. Of what? Of a plane section. It is talking about the plane section about any axis parallel to the centroidal axis. So it is talking about any axis that is parallel to the centroidal axis. So how much that is? So that is equal to the moment of inertia of section about centroidal axis. So how much that is equal to? It is equal to the moment of inertia of the section about the centroidal axis plus, so it is talking about some mathematical term. It is asking us to add something to it. What is asking it to add? It is asking us to add the product of area of the section and the square of distances between the 2 axes. It is asking us to add the product of the area of the section and the square of distance between the 2 sections. So remember, in this particular statement, what important points you have to remember? You have to remember that we are talking about the axis that is parallel to the centroidal axis. Okay, and how much that is equal to? It is equal to the moment of inertia about the centroidal axis and the product of the area of the section and the square of distance between the 2 axes. Okay, I think still many of you are confused. So to understand it better, let us go through this particular diagram. Suppose this is a plane section. Okay, as you can see over here, this is a plane section. The point denoted by G, suppose that is our centroid. The axis passing through the centroid, xx, is nothing but our centroidal axis. Okay, so are you comfortable with this particular term, centroidal axis? So what is centroidal axis? Once again I will repeat. So the axis that passes through, or the axis that passes through the centroid, is nothing but the centroidal axis. Remember that this particular axis is an imaginary axis. It is not present in actual. It's just an imaginary axis. Okay, so the axis passing through the centroid is xx. Okay, now from this centroidal axis, another axis, as you can see over here, AB is there. So this particular AB line or this particular AB axis, as you can see from the figure, it is parallel to this x axis. Okay, So here we can use the parallel axis theorem. So according to this parallel axis theorem, what we will have? It states that the moment of inertia of a plane section about any axis parallel to the centroidal axis. So using this particular parallel axis theorem, we can find the moment of inertia of this particular section or this particular axis AB about the plane section given over here. So if you have to find the moment of inertia about axis AB, so if you have to find IAB, that is moment of inertia about axis AB, what we will have, or how much it will be equal to the moment of inertia of the section about the centroidal axis. So the moment of inertia about the section about centroidal axis will be Ixx, and the product of area, suppose the area of this particular section is A and the square of distance between the two axes. From this particular figure we can see over here that the distance between this axis xx and the axis AB is h. So from this what we can have, we will have the parallel axis theorem, IAB is equal to IG plus AH square. So I have written here IG. What is IG? IG is nothing but Ixx. So the moment of inertia about this particular centroidal axis I have written here as IG. Okay, so moment of inertia I have written here IG about central axis, and the product of the area of the section and the square of distance between the two axes. So I have written it as AH square. So from parallel axis theorem we will have IAB is equal to IG plus AH square. So from this particular figure, for this particular figure we will have IG is equal to Ixx, because this xx axis passes through the centroidal centroid G. Okay. So this question was also asked repeated number of times. Okay, so you can mark this particular question as a very important question. As you can see over here, it was asked multiple number of times, and it was asked for 4 marks. So if this question is asked again, what you have to do? If this question is asked for 4 marks or 3 marks, what you have to do? Or even for 2 marks, you have to write the statement, the whole statement you have to write, you have to draw this figure, and then you have to write this mathematical statement, that is IAB is equal to IG plus A square. You have to write this. Okay, if you don't write IG is equal to Ixx, it is okay, but at least you have to write this. Okay, now moving forward, another one theorem is there, and the name of that theorem is perpendicular axis theorem. So from the name, the previous theorem which talked about the parallel axis theorem, so here we talked about the parallel lines or the parallel axis. Similarly, in this theorem we will be talking about the perpendicular axis. So those axes that are perpendicular to each other, we will be talking about that. So let us go to the statement of this perpendicular axis theorem. So what this perpendicular axis theorem states? It states that the moment of inertia of a plane section about any axis perpendicular to the plane is sum of moment of inertia of two perpendicular axes to the same point in the plane of the object. Okay, so this particular statement is talking about the sum. Okay, so here we are just talking about the addition and nothing else. In the last particular theorem we talked about the product also, and here we are just talking about the sum. Here too, for this lengthy statement we will cut it in the parts. So the first part, the moment of inertia of a plane section. We are talking about moment of inertia about any plane section, where about an axis perpendicular to the plane. We are talking about the axis that is perpendicular to the plane is how much? Is sum of moment of inertia of two perpendicular axes through the same point in the plane of that object. Okay, now to understand it better, let us go through this particular diagram. So for this plane section, as you can see over here, let us consider a plane section. Let us consider a point O. Suppose there are two planes, suppose there are two axes that passes through that plane which are mutually perpendicular. So x is passing and axis y is passing. Suppose these two axes are perpendicular to each other, and another axis, this axis z, is also perpendicular to these two axes, but it is going through that point, it is passing through that point, it is not containing the plane of this particular object, it is passing through it, it is cutting it. Okay, so to imagine it better, let us consider you have book in your hand. Okay, suppose you have book in your hand draw two perpendicular lines to it. Okay, you will get one point where that particular point meets. Assume that point as O. Okay, we will have that point O where those two axes, that is axis X and axis Y, which are perpendicular to each other, will pass. Now put your finger or put your pen on that point in a vertical manner. That is, put your finger on that point, so your finger or that point of your pen is on that book. Okay, suppose that finger is nothing but the axis. Imagine what I'm trying to say. Imagine that finger or that pen is an axis, so that axis is considered as axis Z. Why? This particular axis is passing sorry, this particular axis is passing through that plane. It is not containing the plane. If you are drawing the two lines X and Y perpendicular to each other, they will lie in that plane. But this particular axis, your finger is going to pass through that page. So that axis is termed as Z axis. So in this theorem, we are concerned about this Z axis and we are concerned about the moment of inertia about this Z axis. So from this theorem, we will have the moment of inertia of Z axis, and that is equal to Izz is equal to Ixx plus Iyy. Why? Moment of inertia of the plane of section about any axis parallel to the plane, about any axis perpendicular to the plane. Yes, Z axis is perpendicular to the plane, is sum of what? Two perpendicular axes to the same plane. So two perpendicular axes. So Ixx and Iyy are the perpendicular axes. So the sum of two perpendicular axes Ixx and Iyy will give us Izz. Okay. So this is also another theorem. So this theorem was also asked numerous times. As you can see over here, this was also asked for 4 marks. Okay, you will have various numericals associated with these two theorems. So for this particular theorem also, you have to write a statement, you have to draw the diagram, and you have to write this formula written over here. Okay, remember, this is also a very important point. You have to go through it. You have to go through it very concisely, precisely. Remember, there are lot more chances of these particular two questions, that is parallel axis theorem and perpendicular axis theorem, to be asked in examination. Okay, now let's move forward. So this much was the part of the theorems. Now moving forward, we'll talk about polar moment of inertia. So polar moment of inertia is associated with the perpendicular axis theorem. Okay, so in perpendicular axis theorem, let us go to the previous slide. So perpendicular axis theorem, there were three axes: axis X, axis Y, and axis Z. Axis Z passed through this point. It was perpendicular to X and Y. This Z axis is nothing but the polar axis. And in this particular point, we are going to go through the definition of polar moment of inertia. We will be talking about the moment of inertia about axis Z. Okay, so let us go through the definition of polar moment of inertia. So polar moment of inertia is defined as, if Ixx and Iyy are the moments of inertia of a plane about two mutually perpendicular axes, then the moment of inertia Izz about the third axis Zz perpendicular to the plane and passing through the intersection of Xx and Yy is called as polar moment of inertia. Okay, so what this particular definition states? It states about only Izz. Remember, this particular definition deals with Izz only. Okay, so how this polar moment of inertia is denoted? It is denoted by Izz or Ip or J. You will have different notations in different books. Okay, mostly this point, polar moment of inertia, is concerned with our second last topic, that is of torsion. Okay, in torsion we will be studying this J, we will studying this J, we will studying this polar moment of inertia. We will having the numericals on polar moment of inertia, and we will use those there. Okay, this was also asked once. Okay, it was just asked for 2 marks. This is not that much important, but it is an easy concept to understand. Okay, so this much was about the theory part. Now to begin with the numericals, let us go through some moment of inertia of some plane figures. With the basic shapes moving forward. First basic shape, that is of rectangle. Suppose we have to find the moment of inertia of a rectangle. The first shape, that is of rectangle. Suppose there are two axes, axis x and axis y. Both these axes passes through the center of gravity or centroid. Suppose this is the centroid. Now, for moment of inertia about axis xx, we will have Ixx is equal to b d cube upon 12. Now what is b and d over here? So b is breadth of the rectangle, that is width of the rectangle, and d denotes depth or height of the rectangle. So moment of inertia about horizontal centroidal axis, or as denoted over here, Ixx is b d cube upon 12. And moment of inertia about vertical centroidal axis, as denoted over here as Iyy, is db cube upon 12. Okay, once again, what is b? B is breadth of rectangle. What is d? D is depth or height of the rectangle. Okay, this is the direct formula that we are going to study, and we are going to use it in various numericals coming. Okay, we don't have the theory or the derivation how we got these formulas at our diploma level. Okay, now moving forward, our second section, that is hollow rectangular section. Now what is a hollow object? And hollow object is a cut object, an object which is cut, and that hollow object will have some thickness. Remember, consider the cap of your pen, it's an hollow object. Likewise, if you have a hollow rectangle, means a rectangle is cut within a rectangle, we will term it as an hollow rectangular section. Okay, if we consider the inner rectangle, suppose b1 is the breadth of inner rectangle, d1 is the depth or height of the inner rectangle, b is width of outer rectangle, t is the depth of outer rectangle, then we will have Ix is equal to bd cube upon 12 minus b1 d1 cube upon 12, and Iyy is equal to db cube upon 12 minus d1 b1 cube upon 12. Okay, so both these formulas are same as the above formula, but the difference over here is about just we are going to subtract the moment of inertia of the inner rectangle. Why? Because in hollow object, what we do, we just remove the object, we just remove a section. So because of that, we are going to reduce the inner section, the moment of inertia of inner section for Ixx, and similarly for Iyy. Okay, next, the third particular shape or the third particular plane is circle. Suppose d is the diameter of the circle, then as circle is symmetrical in both x-axis and y-axis, we will have Ixx equal to Iyy, and that will be equal to pi by 64 d raised to 4. Remember, this is the formula for moment of inertia about both axes, that is axis Ixx as well as axis Iyy. Okay, for circle. Now our next object number 4 is hollow circle. What is hollow circle? Hollow circle is just like a hollow rectangle. When a circle is cut through another circle, then we will term it as a hollow circle. It will have two diameters, the inner diameter, which is denoted as small d, and outer diameter, which is denoted as capital D. Remember here, even though it is hollow, it will be symmetric about both axes. It will be symmetric about x-axis also and y-axis also. So the formula for hollow circular section will be equal to Ixx is equal to Iyy, and that will be equal to pi by 64 d raised to 4 minus d raised to 4, that is capital D raised to 4 minus small d raised to 4. Why so? Because we are subtracting the inner circle from the outer circle. Okay, so we'll have pi by 64 capital D raised to 4 minus small d raised to 4. Okay, next, moving forward, the next particular plane is semicircle. Okay, now suppose this is a semicircle, as you can see over here. In this particular semicircle, you can see the centroidal y-axis and the centroidal x-axis. Remember, this is centroidal x-axis. Okay, if we are placing the semicircle in a different manner, suppose if we are placing in this shape, okay, what we will have? We will have a symmetrical x-axis but not so symmetrical y-axis. Are you getting what I'm trying to say? In this particular type of semicircle, we will have y-axis which bisects this semicircle, but x-axis is not bisecting. So this semicircle is not symmetrical about x-axis, but is about y-axis. So let us go through the formula. So for this particular semicircle, the formula is Ixx is equal to 0.11 r/4. What is r? R is radius of the semicircle. And what will be Iyy? Iyy will be pi by 128 d⁴. So how this 128 came? 128 is double of 64. Okay, remember this relation. What is 128? 128 is double of 64. So as this semicircle is symmetric about y-axis and we are cutting it through one half. One half we are neglecting. There was one circle over here and we have cut that circle and we are just having a half circle or the semicircle over here. We are dividing the moment of inertia of circle by 2. So moment of inertia for the circle was pi by 64 d⁴. Okay, as you can see over here, the moment of inertia for circle was pi by 64 d⁴. If we divide it by 2, what we will get? We will get it as pi by 128 d⁴. Similarly, if we consider circle in this manner, for this the circle is symmetrical about x-axis and not about y-axis. So this particular formula, it is pi 0.11 r/4 will be for Iyy. Okay, and this formula, it is pi by 128 d⁴ will be for xx. Okay, I think you got this point. Now the sixth plane is of quarter circle. Okay, now quarter circle, how we will get quarter circle? If we divide a semicircle, we will get a quarter circle. Now for quarter circle, we will have both moment of inertia as equal, and that will be equal to 0.055 r/4. Remember here that here Ixx was 0.11 r/4 in semicircle. If we divide this 0.11 by 2, we will have 0.055. So what we are doing over here, we are dividing a semicircle. We are making it into half. We will get this quarter circle when we divide a semicircle into two parts. So if we divide this moment of inertia by 2, we will have Ixx is equal to 0.055 r/4. Okay, the centroidal axis will be such. This will be centroidal y-axis and this will be centroidal x-axis. Okay, now let us go through the last plane. Last plane is of triangle. So the moment of inertia for triangle are of various types. We'll go through them one by one, and we'll also go through during those numericals also. Now for triangle, we'll have moment of inertia about x-axis, that is centroidal x-axis. We'll have moment of inertia about centroidal y-axis. We need to find the moment of inertia about base of the triangle. We need to find the moment of inertia about an axis passing through the apex of the triangle. So let us go through those formulas one by one. So moment of inertia about central x-axis is bh cube upon 36. Moment of inertia about central y-axis is hb cube upon 48. Moment of inertia about base is bh cube upon 12. And moment of inertia about apex is bh cube upon 4. Okay, so we have 7 planes over here, and using this particular information from these 7 planes, we are going to solve numericals on this section. Okay, I hope you have written all those formulas. You have to write those formulas. Remember, those will be useful for us to solve numericals that will be coming forward. Okay.